If space truly goes on forever, right now, somewhere in the deep cosmos, an exact duplicate of you is watching this exact video. To figure out if that is actually true, we have to answer a deceptively simple question. Does the universe have a physical edge, or does it just keep going? We know the universe started expanding about 14 billion years ago. Because information cannot travel faster than light, we can only see the parts of space where light has had enough time to reach us. When we look out, we are surrounded by a visual sphere. This wireframe sphere represents that observable universe. Because space has been actively expanding that whole time, the most distant light we can detect actually comes from objects that are now 45 billion light-years away from us. When we look at that boundary, we aren't seeing a cosmic brick wall. We are just looking so far into the past that there is simply no past left to see. Measurements of the curvature of space suggest the real universe is at least 1,000 times larger than our observable sphere. To find out if your duplicate is out there, we need to know if there is a physical border further out, or if the cosmos is a boundless trap. If the universe is finite, you might imagine a hard border where space simply stops. But by definition, the universe is all there is. A physical wall requires something to exist on the other side of it, which breaks the very concept of everything. Physics offers a strange geometric workaround. Space can be entirely finite, containing a limited amount of matter, without ever having a hard border. Take a look at this grid mapping a path on a sphere. An ant walking in a straight line seamlessly loops back to where it started. Space might work the same way. Our 3D reality could be curled back in on itself, forming a hypersphere. If you climbed into a spaceship and flew in a perfectly straight line away from our solar system, you wouldn't eventually hit a void. Given enough time, your straight-line trajectory would bend through the curved fabric of spacetime and bring you right back home. This geometry allows the cosmos to be a completely closed, locked system. We get a finite universe, and no impossible walls are required. A finite universe could be shaped like a torus. A ship flying through the center completes its loop faster than one traveling the outer edge. Light from a single galaxy would travel multiple paths, hitting our telescopes from opposite directions at completely different times. You would be living inside a cosmic hall of mirrors. You could watch a star violently explode into a supernova, while on the opposite side of the sky, you watch that identical star forming. These shapes would make the universe feel small, potentially only a few times larger than what we can see. For the odds of a duplicate to become a certainty, we have to move past these finite loops and look at true infinity. The standard cosmological model used by most physicists actually describes an infinite universe. There is no curve bringing you back home and no hidden edge, just an endless expanse of galaxies extending forever in every possible direction. This creates an immediate logical headache. We know the universe has been expanding since the Big Bang. How can a space that is already infinite get any bigger? In this model, expansion is the stretching of the distances between galaxies over time. Even an infinite space can become more spread out. If you traveled outward into this endlessly stretching space, you would pass a continuous stream of new solar systems, strange planets, and completely unknown biology. But while the real estate of an infinite universe goes on forever, the physical matter available to fill all that space hits a strict mathematical limit. Look at how these nodes shuffle. Everything in reality is built from a finite set of fundamental particles, and those particles can only be arranged in a finite number of ways. You have a severely limited number of ways to build matter, but you have an infinite amount of physical space that absolutely has to be filled. If you have an infinite number of empty boxes, but only a finite number of items to put inside them, eventually you run out of unique combinations. The patterns are forced to repeat by pure chance. Finding a second Earth would require traveling a distance of 10 to the 10 to the 29th meters, a 1 followed by 100 octillion zeros. But probability changes when space never ends. In an infinite expanse, the concept of unlikely completely breaks down. A limited number of particle arrangements scattered across an unlimited volume forces exact duplication. The odds of an exact copy of you watching this exact video right now are almost zero. But in an infinite universe, almost zero is an absolute mathematical certainty.